I'm Javier Ramírez from Hoplasoftware. I'm Docker Captain, so many of the things that I'm going to talk about is related to some Kubernetes environments, some Docker environments, but we're going to see how to manage dynamic applications, dynamic infrastructure for modern applications in the common world right now, which is Docker container or container environments. And of course, we have to manage how they interact with some legacy stuff that we have in our environments. Oh, okay. So we're going to talk about dynamic infrastructures and microservices as a concept, something that we have been talking these days, so everyone knows about microservices and what we expect from microservices. We're going to talk about what are the requirements we need to have in mind when we try to manage dynamic infrastructures. Then we will see a couple of tricky environments, some samples that we have used because we are consultants in Spain. So it's something that what we are going to show you is how we, in some cases, we did things in the past, and now how we do this kind of things. And we will try to get all the features that will help us when we talk about NGINX as a reference for us, as a core application in our dynamic infrastructures. So let's start with why do we need dynamic infrastructures? Well, right now, everyone wants to deploy things faster. So we need agile deployments. We need to run everything everywhere because we need to be able to run in our on-prem environment, our applications, and we need to run whatever cloud we choose. We need to scale up and down. When we have a peak in our process, we will scale up, but we need to be able to scale down to allow the consume of our resources to get lower. We need to manage microservices environments. This is very important because dynamic infrastructures are not only something that we were going to use on microservices, but they are quite related. We need to be able to manage these new orchestrations that are available for our container-based environments. And we need to be able to recover from a failure the fastest way we can. So every time we used to move from monoliths to microservices application, we have to choose between a couple of paths. Something that from the consultant's point of view, when we get a customer, they always ask us, which is the right path for going to my monolithic big application to a distributed application made of a couple of microservices or a couple of 100 of microservices. Well, we have to choose between going to modern infrastructure with dynamic infrastructure, building with a legacy application. This is something that Docker calls this kind of approach the MTA, which is modernized traditional application. So we choose, we take a big monolithic application, we take it into containers, we don't change anything in the code, we just take a big container with almost everything. And because we are deploying in Docker or the container platform you choose, we are running in a dynamic infrastructure. So it's something that we choose a legacy application to run in a modern infrastructure. And of course, we can choose going in different way. We can start with changing our code so we choose to run even on virtual nodes, but we break our application into different parts. So we choose to move to microservices without any container. This is something that many customers do, and it's quite interesting because they do the developers have first in mind how to move to microservices, which is something that if you are coming from a legacy environment, the people from infrastructure usually don't have that in mind. So this is a great approach. And of course, if you are brave enough, you can go from monolithic to microservices environment built of containers. It's something that we usually don't recommend because it's quite harder, because you have to involve people from infrastructure and people from development. So it's something that usually don't work very well. What are the challenges when we move to microservices? Well, we need to manage, of course, infrastructure. We have to manage, well, something that we usually have in our container environment is orchestrations. It's something that comes out of box. It's something that we don't care or we don't have to manage in a different way. We have to provide some kind of service provision and decommission. It's something that we're going to see that creating a new service or publishing, or no, not publishing, creating a new service, deploying a new service is something easy in terms of technical way. The problem usually is about the decommission of that service. Something that we have tricks about monitoring and then taking down that kind of service. We have to manage the resilience of the components of our application. So it's something that we have to be to take in mind when we do dynamic configuration. And of course, if we do a couple of releases per day, or we have to manage how we deploy new versions of our components. And of course, when we have to publish the applications, we have to be able to manage the publishing for our consumers. And of course, if we do some kind of CI/CD, we have to be able to deploy and publish internally in our environment through the different CI/CD stages. And how NGINX will help us? We have many features that NGINX out of the box have for us. Of course, we have the load balancing and proxying features. This is something that we're going to use almost in every path we choose. And of course, it's something that we're going to manage using legacy environments, mixing legacy environments with container-based environments. We have the API management, which will help us to allow different applications to talk with each other, something that we're not going to use to talk in this session, but it's something that NGINX provides us. And of course, if our applications are only based on containers, we have what it's called, they call in the past Ingress controllers, and we have a couple of examples. Of course, if you are using Kubernetes, we know that there are the different kind of Ingress controller. We're going to see NGINX and the new features in the new Ingress controller. And there's something that I don't know if many people knows about the Swarm Interlock, which is the Ingress controller environment that Docker Enterprise provides, and it's something that is quite similar of the Kubernetes way of doing things. So let's start with third-party applications, third-party integration. This is something that we usually use in the past. So we can use configuration applications to manage dynamic environments. So we usually use Ansible. So it's something that I can use for add and remove services. So we change the configuration, just reload the configuration. So it's something that is quite easy. So the problem comes when we want to have a configuration that manage idempotency. So it's something that if you don't use Ansible, or of course, if you use Ansible with Ansible Tower or something that manage configuration in intervals of time, you have to be able to reproduce every time the same configuration. So something that you have to manage is not quite easy, but using Ansible, Puppet, Chef, or whatever configuration management tool that you're using, you can do dynamic configurations. On the other hand, something that you usually use in the past, you can use Consul, a combination of in fact, this is a combination of key value store, a watcher, and a template configuration that do all the changes in your NGINX configuration. Usually use Consul with Consul template. This is something that fits very well. And I remember that in the past, if we deploy this kind of things in Docker container environments, for example, usually add another component called Orchestrator that watch for the changes in the Docker runtime, and then if something new appears using environment variables, you can add this service automatically to the key value store. So it's something that usually works very well. And the way we can decommission this kind of services is something that usually is provided using the monitoring environment that is provided by Consul, for example. So if we have some problem with one of the backends, we can easily deliver a trigger to change again and take this backend off of the pool. This is something really cool, and it works very well. We usually, as a trick for you, usually try to create a trigger with the first monitoring health check we deploy in a container, which is very cool because you really don't know if my application or my component is ready until the first check you do in your container. Even if you are using Kubernetes or you're using Swarm, this is something that works very well and is better than using manually or in your startup scripts, your Docker entry point, using a trigger for your key value store. It's better to use health checks for doing this kind of features. And of course, we have many features inside NGINX. So we're going to take a look at probably the main features that we have. So we have active health checks, which is very cool. You are able to check in intervals how is the health of your different backends. So it's something that you have to use for dynamic configurations. We have the DNS Resolver, which is something that we have to provide the entries manually or with some kind of automation to your DNS Resolver, something that is not going to be done by NGINX. And we can use the API, the management API that is provided by NGINX Plus. In fact, all of them are pieces that are available on NGINX Plus. So this is an example of how we can manage health checks. So in this case, we are going to we're going to use to check every 10 seconds, and we're going to retrieve 3 times. And we're not going to just take care of the status of the page. We're going to look for not to avoid a maintenance mode in our page. So it's something that NGINX is going to be. We're not going to change anything in NGINX. So each time we want to take down some of our backends, we just take maintenance mode in some page. We're going to be able to dynamically get down that node from the pool for the backends. So this is something that it's very, very common. This is a picture of how we can do this kind of stuff. It's very easy. So it's something that we usually don't recommend doing these kind of things with passive checks, health checks, because it's not going to work. No one is going to ask if the backend is recovered or not. So you have to do it manually. And in using active health check is something that NGINX is going to do for you. So it's better to use active health checks. On the other hand, we have Nginx Resolver, which is the way we can deploy dynamic configuration based on DNS queries. So in this case, this is a quick example. We will try to query our preferred DNS each 300 seconds, so it's 5 minutes. So each time we have a change in our DNS, we have a different configuration for our backend. So we have a couple of, I don't know, no, it's not there, my mouse. So we use a configuration. We ask for the backends with the DNS. So every time we have a change in our DNS, we'll get a new IP address for our backend servers. This is something that, as I told you before, we have to do it manually. So we have to involve some configuration in our DNS because NGINX is not going to do this kind of changes for us. This is a quick schema of how it works. So we just, every time we do a request, we will try to get one of the backends that are received from the DNS query. And of course, we have the REST API. This is the management REST API. This is very cool because we can manage a lot of things with the API. We can check for the health of our backends. We can add or remove backends quite easily, and we can modify some parameters. For example, the weight. This allows us, for example, in a non-container-based environment, we can deploy blue-green or canary deployments using some different configuration of the weights of the backends. This is very cool and it's very easy. Well, this is a sample of doing a post. So we're adding in an upstream a new server. So it's something that the first time we add a server, the index will change. So every time we try to reference to this new server, we have to manage the index that is related to this backend. So we can delete this backend node, or we can change, for example, in this case, if we want to easily put one of our nodes in down mode, we set to down. In this case, is something that we have put one of our nodes in maintenance mode. But of course, if we talk about containers, is something that is I'm quite near to containers environment. So it's something that we manage in Hopla. We have different options. We have, in fact, they are both the same. They are based on an NGINX by default. The general available environment for NGINX for Ingress Controller in Kubernetes is based on NGINX, and you usually recommend use NGINX Kubernetes environment because it's easier to manage. We know that it's based on NGINX code, and of course, if you have your subscriptions with NGINX Plus, you can use NGINX Plus as Ingress Controller, so you can have Resolver, you can have haptic health checks. If you don't want to use Kubernetes haptic health checks, that's something that is inside Kubernetes, you can use the NGINX feature. And Docker Enterprise provides what is Interlock, which is based on the same concepts we have seen because they use some templates. So NGINX Controller has right now new features that they are very cool because in the past we have this kind of configuration, which is an ingress resource. It's something that if you want to add some features that they are not available in Ingress resource by itself, we have to use annotations, which is kind of tricky, so it's not very useful because every time we have to redeploy or we want to change an annotation is not easier and to manage that kind of stuff. So we usually use config files, and config files allow us, ConfigMaps, allow us to take care of releases versions. But with the change of the new version, we have, this is something that right now is not ready for production, but it's very cool because it reminds me of the configuration of we usually do with NGINX out of box. So it is we deploy, we configure, we set up our host name, in this case with our server name, with the host, and then we just put the upstreams. This is something that if we add the routes, is something that is near the location primitive in NGINX. So we have to be able to, we are able to manage easily this kind of configuration. In fact, the new version allows us to do something that is kind of tricky because we can use different configuration on different namespace. You can name a different namespace configuration. This is something very cool. And of course, there's a primitive, for example, to allow splitting the traffic between a couple of backends. For example, when you deploy blue-green or a canary deployment, so you can use the resources to manage the traffic between the different backends. Of course, as I told you, Interlock is the same concept. It's something that people from Docker deploy using NGINX community NGINX. So they have the common NGINX features that everyone uses out of the box in the community edition. They have dynamic reconfiguration, basic on templating. This is something that is not quite good because if you want to deploy, for example, some specific configuration, you have to change the template that is prepared for all the environment. So it's true that it's something that if you have to, for whatever reason, you have to redeploy all the environment, you will lose this configuration. So it's something that is, because it's based on templates, it's not as easy or as useful as Ingress Controller. This is how the environment will work. They have 3 different components. One is the proxy, which is an NGINX. The other one is which is called, I can't remember. It's I can't say it. Well, in fact, one of them is the template, the extension. Sorry, the extension is the templating process that will change the templates for the backend proxy, the Interlock proxy, and all the. I remember I told you about the Orchestrator, which Interlock by itself is some kind of process that is quite near Orchestrator because it watches for the API changes when a container or a new service is deployed, and it uses templates, labels to know what configuration the Interlock station had to do for the Interlock proxy. So this is the kind of configuration we do with with Interlock. So we just set up the host, which is going to be the host header or the server host header, and the port where the containers are going to deploy, to be listening. This is very important because I don't know if I'm sorry, I think I haven't said before. Using Ingress or Interlock is better than exposing services out of the box, because if you use Node Port or Swarm router mesh, you are deploying something that is going to be available on all the nodes in the cluster. But when we deploy using Interlock or Ingress, the traffic for our services is something that is going to be maintained internally. So we just deploy, so we just expose the Ingress port or the Interlock port, which is very cool because we are able to manage all the traffic between inside one endpoint. So it's quite different because we are not going to fix all the ports that are set up in our services, and we are able to use more than that. So I want you to remind, or the takeaways for this session will be that not all the microservices are based on containers. It's something that we know, but we can or will get the same problems even we are working with containers, or we are working with microservices doing the legacy stuff. We are looking for agility and flexibility. We need to manage dynamic environments. And of course, the key for this kind of configuration is knowing where are our service endpoints, and something that we should, we must be able to manage with dynamic configurations. And of course, if we are using some homogeneous infrastructure, will be easier to manage. It's something that this is very important because the way yesterday I was in a session from Owen, and they are deploying a new service mesh model that is not only based on container-based environments, which is very cool because we want to have the same tools for container-based environments and to legacy environments, because we know that for a long time we want to have both in our data centers. So having a different solution for each environment, I think it's going to be a problem. So if we have some general or common solution for both environments, it will be easier. So that's all I have for you. And thanks for being here. And if you have any questions, many thanks then.